In this video we'll be solving using the quadratic formula. This is the quadratic formula. You notice there are A's, B's, and C's in the formula, and those A's, B's, and C's come from the standard form of a quadratic. So the coefficient in front of the squared term is A, coefficient in front of the x term is the B value, and the constant is the C value. So again, this is the quadratic formula. We can get either a no solution out of it, and in Algebra 1 we stop there, or we can get two solutions or one solution. So the special part, a special part of the quadratic formula is the part underneath the square root, and that is called, I've written it here, the discriminant. So the discriminant is the b squared minus 4ac portion. Notice it does not include the square root. It doesn't include that part. It's just the part underneath. What the discriminant will tell you is whether you have no solution, one solution, or two solutions. So quick review of what the graphs look like. So a no solution situation would be when we have a parabola with a vertex above the x-axis that opens up like that, or it opens down and the vertex is below the x-axis. So that would be no real solutions, and in Algebra 1 we stop there. If we had one solution, it could be a parabola that opens up and just comes down and its vertex touches the x-axis like that, or opens down and the vertex comes up and touches the x-axis like that. That would be one solution. And then two would be opens up, crosses through twice here and here, or opens down, crosses through here and here. So those would be two solutions. So 0, 1, or 2. So the rule is if the discriminant, so that the b squared minus 4ac is greater than 0, that gives us two solutions. If the b squared minus 4ac equals 0, that's going to give us one solution. And if the b squared minus 4ac is less than 0, then that's going to be no real solution. No real solutions. So that is the special part of the discriminant, and that's why we pay attention to it. Okay, so now that we've discussed the discriminant, let's do this first example here and solve this using the quadratic formula. So we have standard form here where the a value equals 1 in this case. That's the multiplier in front of the square term. Our b value here is right here, 3. It's a little confusing with the variable being an a. The c value is negative 4. So we're going to use those when we plug it into the quadratic formula. Now, I didn't say this before, but when we have two solutions, they're coming from this plus or minus sign here. So that's how we can get 2 out of it. So we start. So negative b for us would be negative 3 plus or minus the square root. B squared would be 9. I'm just going to write 9 here. You could write 3 squared and do it later. Subtract 4 times a is 1 times c is negative 4. I recommend you use this format where you use the parentheses there. All over 2 times a would be 2 times 1, so we're just going to leave it 2. So then in the next step you can do as much simplifying as you like in each step. So 9, and then we would subtract 4 times 1 times negative 4. So altogether, if you multiply negative 4 times 1 times negative 4, you get a plus 16. So in this next step, you could go ahead and make that 25 or leave it this way. We'll just leave it that way for now. So in the next step, again, you can shortcut this a little bit and make it 25 right here instead of writing 9 plus 16. Doesn't matter. So right now we have negative 3 plus or minus square root of 25 all over 2. The square root of 25 is 5, so in the next step we'll have negative 3 plus or minus 5 all over 2. So this is where our two solutions are coming from. One solution is going to be negative 3 plus 5 all divided by 2. The other solution is going to be negative 3 subtract 5 all over 2. So in red, negative 3 plus 5 is 2, divided by 2 is 1. So x equals 1 is the solution. Should have used red there. Negative 3 subtract 5 is negative 8 divided by 2. Negative 8 divided by 2 is negative 4. So x equals negative 4. So we have solutions of 1 and negative 4. So we could write them in those braces, 1 and negative 4 like this, or we could use this format here. I usually write it this way. This is the set notation you could use, or we'll use this most of the time. So two solutions, 1 and negative 4. This parabola crosses the x-axis at an x value of 1 and an x value of negative 4. Okay, the second one here, our a value is 1, our b value is 3, our c value is 2. So our a value comes from here, b value here, c value here. We need all of those first, that's our first step, and then we start filling in the quadratic formula. So we'll start here, x equals negative b, so that would be negative 3 plus or minus the square root of b squared is 9. Subtract 4 times a is 1, times c is 2, so that's our numerator. All over 2 times a is 1 again, so 2 times 1 is just 2. Next step, negative 3 plus or minus the square root of. So here I have this part right here, I have negative 4 times 1 times 2, so that's negative 8. So we have 9 subtract 8 all over 2. 9 minus 8 is 1, so we have negative 3 plus or minus square root of 1 all over 2. And again, as you practice this more and more, you can start combining some of these steps. Square root of 1 is 1, so x equals negative 3 plus 1 over 2, and x equals negative 3 minus 1 all over 2 will be our two solutions here. Negative 3 plus 1 is negative 2 over 2, or negative 1. Negative 3 subtract 1, negative 4 all over 2, negative 2. So up here, two solutions are x equals negative 1 and x equals negative 2. So this parabola crosses the x-axis at an x value of negative 1 and negative 2. Okay, next example, our a value here is 1, b value 2, c value negative 5. That's always our first step, identify those. Now fill in the quadratic formula. X equals negative b would be negative 2 plus or minus the square root of b squared would be 2 squared, so 4. We'll subtract 4 times a is 1 times c is negative 5 all over 2 times a is 1 again, so 2 times 1 is 2. That equals negative 2 plus or minus the square root of. So this section we have negative 4 times 1 times negative 5, so that would be plus 20. So we have 4 plus 20 here underneath the radical there. So next step, x equals negative 2 plus or minus square root of 24 all over 2. Now we do have a square root of 24. It doesn't have a perfect square root, so we need to break it down. We need to simplify it. So negative 2 plus or minus square root of. We want to rewrite 24 with factors where at least one of them has a perfect square root. So that would be 6 times 4 all over 2. Next step, negative 2 plus or minus. So the 4 here, square root of 4 is 2, so it's popping out as a 2 there with the 6 staying behind all over 2. Now we can actually cancel. We can factor out a 2 from everything, so that becomes a negative 1. This 2 goes, that 2 goes. So negative 1 plus or minus square root of 6. So our answers, our two solutions, are x equals negative 1 plus square root of 6. That's one of them. The other one, blue, x equals negative 1 subtract square root of 6. So two solutions, negative 1 plus square root of 6, negative 1 subtract square root of 6. Two solutions there. Okay, the next example here, identify our a, b, and c. A is 1, b is negative 3, c is negative 1. So a is coming from here, b from here, c from here. Now fill in the quadratic formula. X equals negative b would be careful here, negative of negative 3 is positive 3. Plus or minus the square root of b squared. That would be negative 3 squared. So negative 3 times negative 3 is positive 9. Subtract 4 times a is 1 times c is negative 1. all over 2 times a. Again, our a value is 1 here. It's not always 1, but in this case it is, so 2 times 1 is 2. Next step, 3 plus or minus the square root of this part right here. We have negative 4 times 1 times negative 1, so that would be a positive 4 if you multiply that all together. So 9 plus 4 underneath the square root, all over 2. Next step, x equals 3 plus or minus the square root of 9 plus 4 is 13, all over 2. And in this case, square root of 13, we cannot simplify that anymore. 13 is prime. Its only factors are 1 and 13, so we have no factors to break it down that have perfect square roots other than 1, so we leave it alone. So we have two solutions here. First solution, 3 plus square root of 13 all over 2. That's an answer. That's a solution. And then we have x equals 3 subtract square root of 13 all over 2. So two solutions there. And this is the correct form to leave it in. This is some decimal value, but we want exact value, so we'll leave it just like that. Nothing else to simplify. All right, last example here, 3x squared subtract 2 equals 0. So it is set equal to 0. Now we identify our a, b, and c. So a is 3. B is, there is no b there because there's no x term. So we're going to say b is 0. C is negative 2. So when we fill in the quadratic formula, everywhere there's a b, we're going to put a 0. So x equals negative 0 plus or minus square root of b squared would be 0 squared, or just 0. Subtract 4 times a is 3 times c is negative 2. Technically, you don't have to write the zeros there. We're just doing it because we're new at all of this. So I'm going to drop the zeros now, plus or minus square root of, right here we have negative 4 times 3 times negative 2. So that would be these two right here give me negative 12 times negative 2, positive 24, all over 6. So we'll simplify this square root first. So we have x equals plus or minus square root of 24. We'll rewrite as 6 times 4 all over 6. Square root of 4 is 2, so it will go in front. So next step, plus or minus 2 square root of 6 all over 6. So in this case we can simplify. We can divide a 2 out. We can factor a 2 out of both of these. So this will become 1 and this will become 3. So we have plus or minus square root of 6 over 3. So our two answers are, here's one, x equals positive square root of 6 over 3, and the other, x equals negative square root of 6 over 3. So those are our two answers on that one, and that is it for this video.